Topic 1A, sampling. So we're going to talk about sampling. We're going to deal with a lot of vocabulary that will be needed throughout this semester. So our first vocabulary word we want to deal with is data. Data is information coming from observations, counts, measurements, or responses. So this is what we call raw data, right? Nothing's been done to it. We go and we measure something, we say, oh, that's 11 inches. We ask someone their age, they say they're 42. We ask someone their GPA and they say 3.5. So it's a piece of data. By itself, it doesn't mean much. But when we put it in aggregate, we add it to other pieces of data, that allows us to come up with statistics. Statistics, with an S on the end, is the science of collecting, organizing, analyzing, and interpreting data in order to make a decision. So statistics is a science, like physics or biology. There's a science to it, and basically it's our methodology for collecting data, organizing it so we can use it, analyzing it, looking at it and seeing what happens, and interpreting it so we can make decisions. So that's what statistics is. So we're in an elementary statistics course. We're doing the beginnings of this science. Now, there are two types of data sets that we deal with. So data sets, that's groups of data, right? Those observations, counts, measurements, or responses. Our two types of data sets we deal with are population and sample. A population is a collection of all outcomes, responses, measurements, or counts that are of interest. To put it simply, I say just all items of interest. If I want to know about MVCC students, then the population is all MVCC students. If I want to know about people in New York State, then the population is all people in New York State. So those are the items of interest. As opposed to a sample, which is a subset of the population. So it's a piece of that population. If MVCC students is my population, then maybe our class is a subset of that or a sample of that population. A parameter, it helps if you spell it correctly. Parameter is a numerical description of a population characteristic. It's a numerical description of a population characteristic, or basically a parameter describes a population. As opposed to a statistic, without an S, which is a numerical description of a sample characteristic. So a statistic describes a sample. Notice the alliteration here. Population parameter, sample statistic. Population, all items of interest. Sample, a subset of the population. Parameter describes a population. A statistic describes a sample. These four terms, population, sample, parameter, statistic, are critical to remember. We need to know those. You will use those all throughout a study of statistics. Well, let's get into branches of statistics. Our first branch of statistics is descriptive statistics. Descriptive statistics involves the organization, summarization, and display of data. Essentially, with descriptive statistics, you describe the sample that you took. You give me a sample with a whole bunch of information, I tell you about that sample. That's descriptive statistics, and that's what we're going to be doing for about 75% of the course, is describing what is in front of us. The second branch of statistics, and the more powerful one, is inferential statistics. Inferential statistics, you think that inference, right? Inferring involves using the sample to draw conclusions about a population. So descriptive statistics talks about the sample itself. Inferential statistics, we look at that sample and we say, what can we tell from this sample about the population, or what can we project onto the population? So this is the powerful part of it, and about 25% of our course is going to deal with inferential statistics. So let's get into sampling, right? Section 1A, sampling. Let's talk a little bit about sampling. Sampling is the manner or method that we use to get our sample, that subset of the population. So we're going to talk about 6 different ways that we can get that sample. The first one is simple random sample. A simple random sample is one where every member of the population has an equal chance of being selected, or every sample of a certain size has an equal chance of occurring. So a simple random sample just means if I take the names of all the students in a class and put them in a hat and mix it up and randomly pull out 5 names, that every student in that class has an equal chance of getting selected for that sample of 5 individuals. That's a simple random sample. Simple random samples are great, they're easy to take, and they give everybody an equal chance of being part. The problem with a simple random sample is there's no guarantee that you're actually going to get a good representation of the population. I could take a simple random sample of 5 individuals in the class and end up getting 5 people of the same gender, race, age, height, color, hair color, eye color, everything you can think of. It's possible. So it does not guarantee that I'm going to get a good cross-section. So what do? Well, we have some other methods that will help us to kind of point in that direction. And one is the stratified sample. A stratified sample, strata, layers, involves breaking the population into subgroups or layers according to some demographic. So maybe we break it up according to age groupings. And then we randomly select samples from each of those strata or layers. So that way we guarantee we get our sample includes people from each of those age groupings. Or we do it by gender, so we make sure we get people from each gender. We do it by hair color, so we get people of each hair color, right? So that's a stratified sample, and it helps to assure that we get a better cross-section of our population. I just eliminated the issue of having them all be identical, because now I'm forcing by some demographic that I break it up into different groups, and I get some of each. Another method is a cluster sample. Populations fall naturally into occurring subgroups that are similar and have similar demographics and characteristics. So cluster sampling takes advantage of that. An example of that might be if we were to go to New York City and we start walking around, you may have heard of Little Italy, Chinatown, right? you go into different parts of the city, and there's this subgroup here where you have people with similar characteristics that are grouped together. That's clustering. We naturally cluster. We tend to be with those that are similar to us. So cluster sampling says, okay, let's take advantage of that, and if we want to get different groups into our study, we go and we take this cluster over here and that cluster over there, and we use them, and that guarantees that we get people of that demographic and people of that demographic. So that's cluster sampling. Another method we might use is systematic sampling. So a systematic sample just means that you use some set method. Maybe you want to find out what type of cereal people buy. So you go to the grocery store, and as they come out of the grocery store, you ask every fifth person what type of cereal they bought. That would be a systematic sample. We're using a method to just make sure that we break it up and don't just ask everybody in a row. It's not quite random. We have a system to it. So that's a systematic sample. Another way that we get a sample is a convenience sample. A convenience sample is literally that. It's the easiest way you can get a sample. It's convenient. If I ask a class to write a survey and have 20 people fill out that survey, how do they get their sample? Well, most of them will take a convenience sample. They will go to their friends and family because they don't want to go out talking to random people, and that's a convenience sample. Some of them will be a little more daring, and they'll just go out and say, well, the easiest thing for me to do is just go outside right now and get 20 people. Me, I know what I would do if I'm in a class and they tell me to do that. But when the class gets done, I just stand up and say, hey, I'll take your survey if you'll take mine. Boom, I just got my 20 people to fill out the survey. So a convenience sample, it's just getting it the easiest way. Now, obviously, a convenience sample, it's not going to tend to be the best cross-section because you're taking what's easiest instead of what's most accurate or the best setup. If you go to your friends and family, there's a reason they're your friends, right? Because you have similar interests, you have things in common. Believe it or not, whether you like your family or not, you do have things in common with your family. Certain things come into play from that, right? So me grabbing the students in my class, well, gee, we all happen to be in the same class. At the same time, we have things in common. So a convenience sample. Not the best, really good though if you want to test out something and see how your survey works, or if there's anything you need to fix on it, or try out an experiment before you go large on it, because you can use a convenience sample to easily get some feedback before you go into spending big money and a lot of time doing a much larger sample. And the last type of sample I want to talk about is a voluntary response sample. So a voluntary response sample. That's when people choose to respond. So those who choose to respond, respond. Those who don't choose to respond, don't respond. Voluntary response means at least you get willing participants. And that's a good thing. It's a voluntary response. So at least people weren't feeling overly pressured. They aren't just trying to get through as fast as possible. They chose to respond. The problem that comes with that, though, is the people that tend to choose to respond are those who have strong opinions. So they may not really be that representative of the whole population. You get the highs and you get the lows. Okay? So voluntary response, easy to get them to respond. They chose to, but there's usually a reason they want to respond. They're the ones that want to get their opinion across. Okay, so that is topic 1A, sampling.